Good morning, everyone. Glad to have you here for our class this morning. As you know, the molecule, the droplets of water. What is the width covered by the spray coming out of the nozzle? So that's the third thing, and then final thing is the discharge rate. This is the volume. This is the volume. The width itself is also a length, so it's just meters. The discharge rate, however, is dealing with volumes of water. So we're dealing here with mils, milliliters, liters, cubic meters. These are all volumes of liquids. When you're dealing with volumes of liquids, they are just, we call it capacity, because it's a volume, but the problem is with the liquids, it doesn't have a shape. It takes the shape of the container. So instead of talking about cubic, because here this is cubic, instead of talking about cubic millimeters or cubic centimeters or cubic meters, we talk in terms of milliliters, mils, for liquids. For solids, for solids we talk about cubic millimeters, cubic centimeters. The solids have their own shape, or cubic meters. But for liquids, although it's volume, it is because they are liquids, we deal with milliliters, liters, and cubic meters. So for the discharge rate today, we will be measuring probably mils or liters according to the time, seconds. But you notice in all of these measurements, they are all according to the unit of time. So time is the connecting factor here, which then will allow us to calibrate, find operating speed, the effective spray weight, and then the volume of water coming out of the nozzle. Okay, having said all of that, and you should really go to the Moodle when the lecture is on Moodle, and you can see the lecture again there, particularly the theoretical part, and then you do your calculations when we finish our practical today. Report, you need to answer the calibration key. There's a question there like the one we did our class in our free class on Wednesday. Okay, sorry Steve. These are the two most popular. These are the two most popular types of sprayers that are used by the farming community in the Pacific. This is the Solo. This is a brand called the Solo. This one, and it's a lever-operated knapsack sprayer, which means you carry this on your back, but the power for spraying it, this is the lance, this is the nozzle where the chemical spray comes up, but the power to be able to do that comes from the lever here. This is where you pump, and the pumping mechanism is, down the back here, is a piston. It's just like a car piston, engine piston. As you pump, as you pump, you can just see the piston going up and down inside. See, going up and down. So it's the diaphragm. Oh, sorry, not the diaphragm. The pumping mechanism is the piston. So this is a piston lever-operated knapsack sprayer. Doesn't need an engine. The power comes from your muscle. And if you look inside, you can just see there's another one here. There's another one here. You can see with the piston has been taken away and the lever to expose down the bottom here. You can see this is where the piston goes in and out. And if you look inside, this one, if you look inside, this is the pressure chamber that I was talking about in class. You can see it inside here. It's another tank inside the tank. The outside of around the pressure chamber inside here or tank is where the chemical is located. And as you pump, the piston pumps the chemical as it goes down. The chemical goes between the piston and the chamber, pressure chamber. And when you pump, the piston goes up into the chamber, carrying the chemical with it, the spray mix. And it's a one-way, what's it called, a one-way valve, which means once the piston gets to the top, well, when it travels up to the top, the pressure opens a valve, allows the chemical to go into the pressure chamber. But when you release the lever and the piston comes down, the valve closes. That's why it's called a one-way valve, so that the pressure inside the chamber doesn't escape. So the more you pump, the more pressure is built up, and unless you relieve the pressure by operating this is the mechanism that opens allowing pressure from inside. It is located into the chamber. This is connected to the chamber, pressure chamber inside, and it's only released when you use this mechanism. You press it, allows the pressure to come out, and the spray as well. So that's the lever-operated knapsack sprayer. So for your report, you need to take a photo of the pumping mechanism. I think it's there in the instructions. So that's the first one. The piston-operated lever-operated knapsack sprayer. Okay, the second type that most of us in the Pacific use is what's called diaphragm, lever-operated diaphragm knapsack sprayer. It's the same thing as the other one. This one is a CP15. You can see in the back. The other one was a solo. This one is a CP15. These are in fact the most common and popular sprayers in the region, the South Pacific or the Pacific. Now, you can also see that the hose where the You can see the sprayer nozzle is missing in this one, but there is one in the one that we are going to see later. But again, it's connected to the pressure chamber, which is, you can see inside here. It's a pressure chamber, similar to the solo. Everything the same, except that for this one, it uses a different mechanism for building up pressure into the chamber. And it uses what's called, you can just see inside here, take a photo of the inside here. You can just see the green color of it. You saw in our notes, in the PowerPoint notes that I used in class, you actually see the disc there. It's a rubber disc, and when you pump, you can see it pushes, it is flexible. It does a similar job to a piston. It gets water and forces the water into the pressure chamber through the one-way valve, building up pressure similar to the solo one, the piston one. And when it comes back down, the valve closes and allows the build-up of pressure inside the chamber. Exactly the same. The only difference between the two is the fact that this one uses a diaphragm. It's called a diaphragm, while the other one uses a piston. Okay? So, if you look through the procedures that's there for the two, I think what we just talked about just now should cover those. Is there anything else there that needs to be explained? This one is, if you look at the side, normally they have measurements on the side, and you can see 15 up here. That means it's a 15-liter capacity knapsack sprayer. The same with this one, it's also 15. In fact, most, if not all, of these lever-operated are seldom 20 liters. If 20 liters is too heavy, so the approximate, water, 1 liter of water is 1 kilogram. It has a weight of scientifically speaking, has a mass of 1 kilogram. 1 liter of water has a mass of 1 kilogram. So if 15 liters, that's 15 kilograms you'd be carrying on your back. So this 15 kilograms is pretty heavy. So 20 kilograms is, you take 2 knapsack sprayers, sprayer loads, and I think you're ready to go to sleep. Too tired. Okay, what else?
Serial number. Serial number.
Okay, so that you have to come and find out. Anyway, this is a Cooper, Pegler and Company Limited. That's the one.
The make.
That's the make. That's the company who made it. The model is CP15. Now you will have to find the serial number for this one. Is it right? Okay. Oh yeah. Come and read it out, please.
There's no number.
Oh, okay. Cooper, Pegler and Company. Okay. Okay, sorry, this one doesn't have a, okay, it doesn't have a serial number, this particular one. So I think they just stopped at the model number.
No serial number?
Yeah, because these are pretty, they're exactly the same. A serial number is a number that's a particular to a particular machine. So things like your car has a serial number, and that's the only car that has that number. But it will have the same model numbers as all the other models, but it will have one single different serial number specific to that car. These ones, I don't think they have serial numbers because they're too common. There's nothing that will need it to have a serial number. Okay, so just take the model and the make. Okay. Anything else then? Okay. All right, then I think we are ready to, except for one more thing. If you come around here, this is the mist blower. We had a look at this one when we had one of our former practicals on different types of engines. This is a mist blower or a motorized knapsack sprayer, and it's powered by a two-stroke engine. This is the two-stroke engine here, and the flywheel is adapted so that it becomes a fan and blows air through this blowpipe here. The chemical comes from here, and it comes down this hose and comes all the way down here, and then the chemical and the air meets down here, and then it's sprayed out onto the crops. So this is the other type of knapsack sprayer, common in the Pacific, and it's a popular one for spraying the chemical for banana. What's the name of the disease? Streak. Black leaf streak. It's a fungus. The punchy top is a virus. So you can't control a virus. You just have to take it out and remove it from the plantation or burn it. But for fungus, you can control it by spraying the leaves. The other name for it is what? Singatoka disease. I think we're ready to go outside and do our measurements. We're not. Can we come down, please? Now we're ready to. Kenneth just come back after rinsing the Solo. This is the Solo 15 one. Oh, it's a Solo one. It's been used for chemical spraying, so he just came back rinsing it. You gotta be careful because anything where we deal with chemicals, be sure that you don't get yourself into problems of poisoning from chemicals. So we just had it rinsed. What we're going to do now is he's going to put some water into the knapsack sprayer to fill it up, because what we need is to find our operating speed. So we are not going to be doing any serious spraying. So just enough for us to make our 3 runs. So maybe just after halfway market here. Yeah, okay. It's about a third of the way. 6 liters. Let's see.
No.
So, okay. So can we all come here to this side and leave the cement so that we can, I think it's better, it's easier for us to measure the effective spray width if you can see the wet surface of the cement. So come on to this side and leave cement. Yeah. So we need to lay out the tape, please. Can 2 of you come and lay out the tape, 20 meters?
maybe start from the other end. Well, I mean, it on the ground. Bring a mark. Okay, so we now instead of 20, we are doing it on 15. So it's 15 meters distance. Okay, so the zero mark is over there. There's a mark there. And here we have the other mark for the 15 meters. So the person who's going to do the spraying will start from there. We'll time it. And when he gets to the 15 meter mark, we stop the stopwatch. Racing is going to be the timer. So you walk along. Who's going to walk with him? So that when he starts over there, you start the stopwatch. It's 60.
So start there and then I stop in 15.
Yeah. So as soon as he starts, you start with him. So when you spray, you are spraying. I think you. Yeah. Okay. So you can come here if you like and go this way. That's the width there. Whatever this is. You work with him. Just to the mark. Yo. Music. Okay, you notice I put a mark here. So I've estimated that the effective spray rate is from the tape to this point here of this mark. So we will measure that later for our effective spray rate. Okay, so that's run number one. What's the second?
1 minute and 9 seconds.
So 1 minute, 9 seconds. Run number one. 1 minute,
9 seconds.
1 minute, 9 seconds in run one. So run one, it would be time taken to travel 15 meters. So you do the calculations on that.
1 minute and 9 seconds. 15 meters.
1 minute, 9 seconds.
I will set this in that time again.
Yeah. Run number two.
54 seconds.
So this one is a bit slower. This is run 2, 54 seconds. 54 seconds. Run 2,
Faster.
54 seconds.
Faster than the first one.
Yeah, but that's how you get to the most accurate average. That's why it'll be different all the time. But you average those and you get to a more. The more times you do it, the closer you are to the real distance. So we do another one. This is run 3 coming up.
Spray Steve again.
What's the time?
1 minute and 53 seconds.
1 minute and 53 seconds. I think Tanel was deliberately slowing down. Anyway, I just want to remind you that the crop protection specialists don't recommend that you walk on the area that you sprayed, so maybe we did it a bit the wrong way, but still take it into account. You really should be spraying going backwards. Yeah? Okay, never mind. The idea is to trying to find the time. So let's run 3, 1 minute,
53 seconds.
53 seconds. So, okay, let's do a last one and then we'll go on to the other one. Done. Okay, yeah, are you ready? Okay, so we're going to do the last one and then we'll do the average. So this is run 4 and I've asked Janet to walk backwards so that it doesn't walk on the sprayed area. You go ahead, please. Okay. So now he's walking backwards so that, but don't have to rush because you think you're going too slow. You don't have to slow down because you think you do fast. Just do it the way you think is the best way of spraying. But make sure you cover up to the tip. So I think that way is a bit more correct. So now he's spraying, but he's not walking on the area that he just sprayed for the sake of safety. Good.
1 minute and 32 seconds.
That looks more correct. 1 minute. Round 4 is 1 minute and 32 seconds. So those are the time taken to travel 15 meters. So you take an average of that, and from that you work out meters per second. So we'll use the second as a, you can use the second or the minute, like meters per second or meters per minute. Okay, but in this case it's probably easier to start with meters per second and then see if you want to move on to meters per minute. Okay, and the last thing we need to measure, of course, is the effective spray width. And what we've done here is we've taken out the tape so that we can measure it. Now, yeah, just put it on this side of the tape. So I put in a mark here to know where the tape was, so we can use it to measure. And it is
1 meter.
80 centimeters. Oh, sorry. This is 2 meters. This is 1 meter. So it's 1 meter, 1.8 meters.
1.8 meters.
1.8 meters.
It's
1.800 meters. So 1.8 meters is the effective spray width. Yeah. So that's the last measurement for you to be able to do the calculations. Okay, so the third thing we need to measure is the discharge rate. This is the amount, the volume of spray mix coming out of the nozzle per time. So it could be mils per second, mils per minute, liters per second, or liters per minute. Up to you how you convert. So we're going to spray into the bucket and measure the actual volume coming out. I think we'll do it for 30 seconds.
Okay.
So we measure the volume after every 30 seconds.
30 seconds.
But here you don't walk, you just come here and spray into the bucket. Spray like you were doing there. So with blessing, you coordinate.
30 seconds.
Yeah. So you need to tell him when to take it out.
Okay.
When you're ready.
No problem. Tahu tu lah tu kena tahu. Tahu. Dua. Yep.
Yeah. So Ken is now using a measuring cylinder. This is a 1 liter measuring cylinder. So again, this exercise allows you to measure volumes. So the first thing, of course, you need to do is work out the volumes. As you can see here, this is 1,000 mils, which is 1 liter from the bottom up to here. And you can see this is 900, 800. That means from here to here from 1,000 to 900 is 100 meals. So that means this line is 50 meals. From here to here is 50 meals. So 1, 2, 3, 4, 5. So that means each of these lines is 10 meals. Yeah? Okay. So where are we? Up to here is 600 meals. And then 610, 20, 30, 40, 50, 60. 660 meals. 660 meals. Run 1, 660 meals. That means run 1, time taken, volume collected in 30 seconds. 60 meals. Volume collected in 30 seconds. Okay? Run 2.
30 seconds.
Yeah, same. All throughout 4 runs. Nice squeeze. So 700, 710.
710.
Because each of these divisions is 10 meals. 710 meals. This is run 2, 710 meals. So you see there's a slight difference. This was a little bit bigger. But that's how things are in real life. You never have the exact amount. So, which is why we do it several times to get the true average. So this is run 3. Run 1 was 660 meals. Run 2, 710 meals. Yeah. Now, total 4,000.
Yep.
Somebody make the reading.
699. 690.
685.
685. So run 3 is 685 meals collected in 30 seconds. 685. So around about Similar.
Yes.
Okay. So we do the last one. So the more you do this, the more accurate your estimate.
And smile at the camera. Hey, you stop pressing time. Stop.
Start right up.
It's 5
Yeah.
or 7. No, it's the same.
749. 749 mules. This is 1/4. 749 mules. Okay, so those are the numbers. You then use that to come up with your discharge rate of the volume coming out according to the time. So that is those are the tools you need to answer the question. There's a question down at the end of the you need to answer just like we did with our lecture on Wednesday. You need to work out the problem given to you using the measurements we did today. Are there any questions? Okay, you download our work plan on the Moodle page and you will find the date for submitting. For face-to-face students, you have a different submission date because we have done it today. But the blended students need to see this on the Moodle page, so we've given them an extra week to submit after the Alafua Campus face-to-face submission deadline. So, best of luck. Have a nice weekend. So far, so far.